Yeah, so photochemistry has been hampered in the last couple of decades, and in my opinion there are two reasons. The first one is that you have to use UV light to get the reaction going, and this is a very high energy source, which makes that actually you're damaging the molecule. So recently the group of Macmillan in 2008 sparked the interest for photoredox catalysis, which allows you to use visible light photochemistry. This is much milder chemistry, and you can have a plethora of different reactions which you can accelerate. The second problem is that you cannot scale photochemistry, so everybody is aware of the Lambert-Beer law, which hampers the scalability of chemistry. So the thing is that actually what happens is your light is exponentially decreasing in your sample, so you cannot use a dimension enlarging strategy, which is typical for organic chemistry, to scale it. So what we do is using microreactor technology, which has very narrow dimensions, and this allows you to have a perfect light penetration of your reaction sample. The key challenges are actually, it's still the same as in the beginning of this area. So microreactor technology started about early 90s, and we are still facing the same problem, which is clogging. If you have a reaction that generates solids, it will clog the reaction. The other thing that we have worked on this by using ultrasound. And what we are now trying to do also is looking into the energy efficiency of our photomicroreactors, because now we are just irradiating with a continuous source of light, but can we make sure that every photon counts, or at least that we have a very useful energy efficiency. In my opinion, this question is, it embraces two main aspects of photochemistry. So first of all, so you have the gas-liquid phase, which is, if you do this in a batch reactor, you have a lot of gas in your overhead, which means that the gas has to diffuse into the reaction sample. When you're doing this in a microreactor, you can increase the interfacial area substantially. This means that you can accelerate the reaction. Second thing is that photochemistry, as I already said in the questions before, you can have a favorable Lambert-Beer limitation, which means that you have a useful and a perfect irradiation. So actually you win 2 times with one solution.